Three Chinese astronauts thought they were coming home after 6 months in space. Instead, their ride back may have been damaged by invisible space debris, leaving their return uncertain and their safety in question. This is a situation that could turn dangerous very fast, and some experts say it's even more serious than the SpaceX Dragon incident. Let's break down what really happened on China's space station, why this situation is so risky, and how close this came to becoming a full-scale space emergency, because what happens next could change how we see life in orbit forever. The incident: how 3 astronauts ended up stuck in orbit. Space looks calm when you watch it on a screen, all blue horizons and smiling astronauts floating in slow motion, but right now 3 Chinese astronauts are facing a much darker reality, as they're stuck above Earth with no guaranteed ride home. Their mission was supposed to end like every other one, with a smooth return and a safe landing, but instead it has become one of the most uncomfortable and risky situations China has faced in orbit so far. How do astronauts end up stuck in space after everything seemed to go right? How does this become worse than the SpaceX Dragon incident? And what happens when your only way home might not be safe to use? In April 2025, China launched the Shenzhou 20 mission to its Tiangong space station. The spacecraft carried 3 taikonauts, which is what China calls its astronauts. Their job was to live and work on the station for about 6 months. During that time, they ran science experiments, checked and repaired equipment, tested new technologies, and helped China keep a permanent human presence in orbit. This is a big deal for China because it built Tiangong after being left out of the International Space Station program. The United States and its partners did not allow China to join the ISS, so China decided to build and run its own space station instead. Tiangong means heavenly palace, and it is China's home in space. It orbits Earth about 400 kilometers above the surface and travels at a speed of over 17,000 miles per hour. That means it goes around the planet roughly once every 90 minutes. The station has 3 main parts. The core module, called Tianhe, is where most of the control and living happens. 2 other modules, Wentian and Mengtian, are used for science experiments and extra space. Inside, everything is carefully controlled. The air, temperature, and pressure must stay stable all the time. The astronauts also need to exercise every day to stop their muscles and bones from weakening too much in zero gravity. For more than 6 months, the Shenzhou 20 crew lived this daily life in orbit. They followed a strict schedule. They studied how plants grow in space, how materials behave without gravity, and how the human body changes during long missions. They also did spacewalks to check and upgrade parts of the station from the outside. By the time their mission was almost over, everything pointed to another smooth crew change, just like China had done several times before. Then came the arrival of their replacements. In early November 2025, the Shenzhou 21 spacecraft launched with 3 new taikonauts on board. The docking was fast and precise. In just a few hours, Shenzhou 21 lined up with the station, connected to the front port of the Tianhe module, and locked in place. For a short time, there were 6 people living together in Tiangong, which is the maximum number the station can hold. The handover between the 2 crews looked almost perfect. They shared information, transferred duties, and officially passed control of the station from the old team to the new one. Chinese state media showed this as a proud moment. The astronauts were smiling, floating around, and even showing new living equipment that the fresh crew had brought with them. This included an upgraded space oven and a better microwave. In one video, they were heating pre-packed meals, including chicken and ribs, and giving thumbs up to the camera. For people watching on Earth, it almost looked like life in space had become normal, comfortable, and even a little luxurious. But space missions can change fast. Even when everything on the inside looks calm, the outside is full of danger. Earth's orbit is crowded with debris. These are broken pieces of old satellites, parts of rockets, and tiny fragments left behind by past collisions. They move at extreme speeds, often faster than a rifle bullet. A piece of debris no bigger than a coin can punch a hole in metal if it hits at those speeds. Not long after the handover, Chinese space officials announced worrying news. They said the Shenzhou 20 spacecraft, the one meant to bring the outgoing crew back to Earth, may have been hit by orbital debris. They did not share many details, but they confirmed that an impact was suspected and that more checks were needed before the crew could return. So, can something the size of a marble really stop a spacecraft from bringing people home? Yes, because at orbital speeds, even a tiny object can crack windows, damage heat shields, or weaken the structure of a capsule in ways that make re-entry too risky. The astronauts were supposed to return home just days after the handover ceremony. They had already spent over half a year in space. Their bodies were stressed from living without gravity. They were ready to see their families and feel Earth's gravity again. Instead, they were told that their return was being delayed until engineers could figure out how bad the damage was. In space, a delay like this is not small. It means more time in a closed environment, more time facing physical stress, and more time relying on equipment that was never meant to be used so much longer. Why is this worse than the SpaceX Dragon incident? Because in the Dragon case, there were backup options already nearby and tested, while here the damage hit one of the very few vehicles China had in place, reducing the number of safe escape routes for everyone on board. For a moment, everything had looked smooth and controlled. Two crews were laughing together, heating food, and showing the world how normal life in orbit had become. And as the smiles faded and the cameras turned away, the biggest danger wasn't outside the station. It was the damaged spacecraft waiting quietly at their door. Space junk and human bodies. Right now, and this part should really unsettle you, Earth's orbit has become a fast-moving field of invisible weapons, where millions of metal fragments race around the planet and can damage a spacecraft without any warning at all. And the Shenzhou 20 situation is a recent and serious sign that this danger is no longer just a theory but a real threat to people living in space. For years, scientists warned that space junk would eventually start affecting human missions, but it often sounded like a future problem, until a modern return vehicle may have been hit while astronauts were still depending on it to come home safely. So, how fast does space junk really travel? The answer is alarming, because both the space station and most debris move at around 7 to 8 kilometers per second, which is over 17,000 miles per hour, meaning they can circle the entire Earth in about 90 minutes. At those speeds, even a tiny object just 1 centimeter wide, about the size of a small marble, carries so much energy that when it hits metal, the impact can be similar to a hand grenade exploding on contact. This is why space debris is so dangerous. It is not about size, it is about speed. There are many types of debris floating in orbit right now. Some are old rocket stages left behind after satellite launches, some are dead satellites that stopped working but were never removed, and some are broken fragments created when objects collide or when countries carried out anti-satellite weapon tests. There is also very small debris, like paint flakes and tiny bolts that came loose over time. On top of that, there are natural micrometeoroids, which are tiny pieces of space rock. Human-made debris and natural micrometeoroids are different, but both can damage spacecraft because they travel at extreme speeds. This danger is not new, and we already have real examples. One well-known incident involved the large robotic arm on the International Space Station, which was punctured by a tiny piece of debris. The hole was small, but it showed that even strong materials could be damaged by fast-moving fragments. There have also been near-miss events where large, abandoned rocket stages passed dangerously close to colliding with each other. If they had hit, thousands of new pieces of debris would have been created, making the problem even worse. The Shenzhou 20 issue fits into this pattern that has been building for years. Every time debris causes damage or comes close, experts warn that Earth's orbit is becoming more crowded and risky. But global efforts to reduce this problem have not kept up with the speed at which we are filling space with new satellites and launches. If we know how dangerous space junk is, why didn't we see this coming? It has to do with how space agencies track many objects, but that doesn't mean they can track everything. On the ground, powerful radar systems and telescopes monitor thousands of satellites and large debris pieces. They use this data to predict possible collisions and sometimes change the orbit of a station or satellite to avoid danger, which are called debris avoidance maneuvers. Space stations are also built with protective layers called Whipple shields. These are made of multiple layers of material designed to break up and slow down small debris before it can reach the main body of the station. But this protection is not perfect, especially for slightly larger fragments or objects that hit at unlucky angles. The biggest problem is that many dangerous pieces of debris are simply too small to detect reliably. Most tracking systems focus on objects larger than about 10 centimeters. But the most risky pieces can be just 1 or 2 centimeters. They are too small to track properly, yet large enough to punch through parts of a spacecraft. These are the invisible bullets of orbit. This is why a strike like the one suspected on Shenzhou 20 can happen without warning. There may have been nothing unusual on the tracking maps, nothing that showed a clear risk. Only later, through inspections or strange readings from sensors, did engineers suspect that something had hit the capsule. This shows that even with advanced monitoring, space is still full of blind spots, and danger can come from objects we cannot even see. The hardware risk. There is also the human cost of staying longer in orbit. Life in microgravity is hard on the body. Without gravity, muscles slowly weaken and bones lose density because they no longer have to support the body's weight. Astronauts exercise every day, but they cannot completely stop these effects. Over time, this can make it difficult to walk or balance properly when they return to Earth. There are also changes in how blood and other fluids move in the body. In microgravity, fluids shift toward the head, increasing pressure around the eyes, which can affect vision. Some astronauts experience blurry vision or lasting changes after long missions. On top of that, there is more exposure to radiation, because Earth's atmosphere and magnetic field protect us on the ground, but that protection is weaker in space. Like, comment, and subscribe.